Infrastructure is under constant assault. When thousands of tons of heavy freight roll over a highway, the underlying subgrades compress and settle, and the asphalt wearing courses crack and splinter under the stress. A physical collapse is often a symptom of a systemic vulnerability. Governments, the principals paying for these projects, do not build roads themselves. They hire private contractors, the agents, to execute the work across vast, decentralized networks. This creates an inherent risk. The contractor's incentive to maximize profit directly opposes the government's need for high-quality, durable materials. Structural engineering provides the physical design, but contractual engineering ensures the contractor follows it, writing rules so tight that cutting corners becomes mathematically and logistically impossible. To see exactly how this is done, we are going to look at two primary blueprints: the National Guidelines for the Pradhan Mantri Gram Sadak Yojana, India's massive rural road network, and the specialized tender documents from the Madhya Pradesh Public Works Department. The operational philosophy of the PMGSY is printed directly in their quality control handbook. Building a road requires relentless testing and merciless quality control. To understand how a highway physically survives, we have to reverse engineer the legal procurement DNA designed to constrain the contractor who builds it. Deploying tens of thousands of kilometers of paved roads across remote rural geography introduces a massive logistical blind spot. A state engineer cannot physically monitor every shovel of earth or pour of concrete. To close that blind spot, states deploy formal tender amendments. This document from the Madhya Pradesh PWD modifies standard conditions of contract to impose strict quality assurance metrics on road and bridge works. Manual oversight relies on trust, and at the scale of a statewide infrastructure grid, trust is a failure point. If a supervisor looks away, a substandard layer gets buried forever. The state replaces trust with a contractor constraint matrix. This is a system of administrative barriers, economic enforcement, mandatory mechanization, and intense on-site verification that lock into place over every physical layer of the road. The tender document effectively translates the laws of physics into a series of non-negotiable legal prerequisites. The first layer of this matrix stops systemic risk before a single piece of equipment arrives at the site. In open bidding, contractors often deploy a strategy of quoting unworkable rates. They submit a bid so aggressively low that they win the contract, but physically cannot build the road to specification without losing money. Their plan is to recoup their profit margin by secretly stripping out material quality. To neutralize this, the government inserts an economic hazard. Item 5 introduces an additional performance security. The math works like this. If a contractor's bid drops more than 10% below the probable amount of contract, the state flags it as unworkable. The state then calculates the exact difference and forces the contractor to deposit that amount as an upfront performance guarantee. If you want to bid artificially low, you have to lock up your own working capital to cover the gap. By eliminating the financial advantage of an unworkable bid, proactive economic deterrence acts as the invisible first structural layer of the road. Once the contract is economically secure, the matrix moves to the execution layer. Humans get tired, lose focus, and make uneven measurements. For critical pavement laying, modern state specifications explicitly reject manual labor. They demand specific technological inputs instead. Look at the equipment requirements for concrete roadworks in the tender. A contractor is legally required to use a batch mix type concrete plant and a slip-form sensor paver. A slip-form paver equipped with electronic sensors reads a physical string line or digital model to extrude the concrete. It calculates and adjusts the camber and thickness thousands of times per minute, far more reliably than a crew with hand tools. By mandating computerized machinery right inside the legal tender document, the state neutralizes the variable of human error on the job site. Perfectly leveled concrete and asphalt will still fail if the raw chemical inputs are compromised. If a contractor uses untraceable, diluted, or low-grade bitumen, the binder will fail to hold the aggregate under thermal stress or heavy traffic. To force traceability, Item 7 requires contractors to source bitumen exclusively from domestic public sector refineries. They tie this directly to cash flow. Contractors must upload digitally verifiable invoices and quality test certificates with every running bill. Physical material integrity is rigidly enforced through a digital financial gate. If the chemistry isn't proven, the payment is blocked. The final, most exhaustive layer of the matrix involves verifying that the executed work actually matches the design standard. The PMGSY framework outlines a three-tier quality control mechanism. State and national quality monitors conduct randomized inspections, forming the second and third tiers. But those external audits rely entirely on a continuous stream of data from Tier 1, the contractor's own mandatory field laboratory. This tender annexure explicitly defines the minimum acceptable scientific capability for that field lab. Under the general category, contractors must possess electronic weigh balances accurate to 0.01 grams, thermostatically controlled ovens, and standardized sieve sets. To prove soil compaction, the state demands specialized equipment, like a California bearing ratio apparatus with a 5-ton load frame. To verify chemical properties, they must deploy penetrometers and sockslit extraction equipment for binder analysis. The consequence of this table is absolute. A contractor cannot even qualify to bid on the project without legally proving they own or lease this exact instrumentation. In modern public works, you are not allowed to build what you cannot scientifically measure and prove on site. Generating scientific data in a remote field lab creates an administrative challenge. How does the central government actually review thousands of localized tests? They ingest it into a centralized digital infrastructure. The PMGSY utilizes the Online Monitoring and Management System, or OMMS. Data is entered at the point of origin. Test results from the field laboratories bypass local paper bottlenecks and are uploaded directly into a transparent database. This pooling of data allows state and national agencies to track real-time quality metrics across thousands of independent work sites simultaneously. The OMMS functions as a digital nervous system, bridging the bureaucratic rules in the capital with the physical reality in the dirt. These three systems, economic deterrence, mandated mechanization, and localized scientific verification, form the core of the constraint matrix. True structural engineering at scale relies entirely on ironclad contractual engineering. A durable public highway represents the physical output of a multi-tiered bureaucratic algorithm, translating rows of equipment tables into stable layers of pavement. Every physical layer of that cross-section is held together by the legal clauses that demanded its perfection. Mastering the principal agent problem through systems engineering is the only way to build enduring public infrastructure.